17 of our notes. It's our last day of our notes for the chapter.
Yay.
We are continuing to talk about angles.
Really?
With our conversation about angles today, we are just adding the fact that it is possible for angles to have the same measure. Do you remember what the word for having the same measure is? It starts with a C. Congruent. It is possible for angles to be congruent. Much like with segments. When we talked about segments being congruent, we could have a picture of the two segments where they have a congruent symbol on them. We could say that their measurements are equal, or we could say that they, by name, are congruent. Angles have three different ways that we can reference that they are congruent to. Angles don't have tick marks, but they have something similar known as angle marks. Angle marks are these little arc things that they put between the rays next to that vertex. So angle A and angle B here are congruent. If I want to say their measures are equal, make sure you're putting the M in front of their names. M, angle A, M, angle B. If I want to say that they are truly congruent, I use their names without the M's, and I write that they are congruent. There are extra note packets up here if anyone needs them. Now, when we have congruent angles, often what makes them congruent is they were cut through the middle. Something went directly through the middle. Something going directly through the middle of something is said to bisect it. We talked about bisect with segment bisectors. We also have angle bisectors. So if I have this angle here, I'm going to call it angle ABC. I can say that that angle, angle ABC, is being bisected by something that divides it into two congruent parts. To divide an angle into two congruent parts, you have to have a point on the interior of the angle, smack dab in the middle of the original rays, and so it looks something like this. And we would say that ABC is bisected by BD, or the other option, and you don't have to write both, but more commonly, they write this, that the ray bisects the angle. Now, when it bisects, that means this is congruent to this. Now, you'll notice that when I have two congruencies right next to one another, I tend to put the single angle mark a little bit further away from the angle on one side than the other. That way it doesn't just end up looking like one arc. Now, one arc going through the middle of this actually has no context. It wouldn't make any sense because you can't put the congruent angle marks through angles that are cut into pieces. But I do tend to stagger them just so they look a little different. You don't have to do that. One other thing about angle marks is it has a similar idea as segment tick marks. If you wanted to say multiple segments were congruent, you put different amounts of tick marks. Angles, you could do the same thing. If I have multiple sets of angles congruent, all of a sudden I just increase the number of angle marks. So, today you're going to get problems like the following. TR bisects angle STU. The first part is the description of what you're looking at. Now, I happen to give you an angle here to start off the process. Sometimes I will, sometimes I won't. First thing you want to do is we want to label your angle. If I am calling this angle STU, does it matter where I put the letters ST and U?
Yeah.
Yes, specifically which letter?
T.
T has to go
Middle. Or on the point.
on the point, on the middle, on the vertex. S and U go on each side. And if I want to write that TR bisects it, then I'm going to draw a ray as best I can through the middle. That's my ray TR, which means it needs to have a point R on it. And then I am also going to mark that these two angles are congruent. Now in this particular problem, we are told that the measure of angle STR, T's the middle letter, goes towards S, goes towards R, that's this one, is 28 degrees. And we are looking to find the measure of angle STU. Is STU the other little one or is it the big one? T's here, goes towards S, goes towards U. Yes, it's the big one. If this is 28, how could we find the measure of the big one? These are congruent. Not this one and STU. These two are congruent. And if those two are congruent, that means this little angle right here is 28. Now that doesn't answer the question.
Don't you have to add them together?
Add them together. Angle addition postulate at play. Add them together. We get 56. So the measure of angle STU equals 56 degrees. Now, they're not all going to be quite that simple. Some of them may be, but not quite all. Many of them are going to be more like the next problem that says BE bisects angle FBD. So, label my angle first. Am I picky about any of the letters?
Yes.
Which one?
B.
At what part of the angle?
Vertex.
The vertex. F and D on the other sides. To bisect means to cut in half. More accurately, it means to cut into two congruent parts. That's essentially, it's a fancy way of saying in half. So, I draw through the little middle. What letter do I need to put on this? E, because that's ray BE. And then I mark these as congruent. Now, if you don't make it perfectly in the middle, that is okay. That's why we mark congruent symbols. Because you can't actually tell if something's perfectly in the middle without measuring it in a geometry picture. And even then, the only way you're guaranteed that they are congruent is if you're told they are congruent. Either by the angle marks, by something saying their measures are equal, or something saying they are congruent. Okay. If you liked working with the highlighters, if the highlighters helped you yesterday with labeling things correctly, feel free to grab some highlighters. If you felt that that didn't help you yesterday, that's okay. You need to do what works for you. I just give tools, and highlighters tend to be something that helps. The first angle is angle FBE. Is that the left side, the right side, or the big one?
Left side.
That's the left side. B is the vertex going towards F, going towards E, makes that the left side. 4x plus 16. The next one is EBD. Is that the right side or the big thing? It's the right side. B is the vertex. Go towards E, go towards D. That is the 6x plus 4. My goal is to find angle FBD, which is the big one. Now, yesterday we talked about the fact that when it comes to finding angles, the big angles, when we have the two small parts, we can add up. It's that angle addition postulate. This angle plus this angle is the big angle when we have those adjacent angles. But if I add up the two measurements I know, am I going to get just a number this time? No, I'm going to get an expression involving x. When I ask you to find something, do I want x still in it?
No.
No. So, I have to take a different approach. What do you know about these two angles? They're congruent. Congruent's a fancy way of saying they are equal. 4x plus 16 is equal to 6x plus 4. If I have x on opposite sides of the equal sign, am I just doing what they say and combining like terms, or am I doing opposite operations? Opposite operations. Subtract the 4x. 16 equals 2x plus 4. Typically from this point we do just fine on solving. Do you trust my solving skills? Not at all? It's good to have a healthy distrust of my solving skills. I'll be honest, because I do make mistakes. I can generally do it, and you get 6. I have been doing this math longer than y'all have been alive and everything.
So like 6, 7 years.
Bro.
You're 6 years old? Interesting. Okay. X is 6. Is that what it asked for? No. No. What did it ask for?
It asked us to find that.
Do we have an expression for FBD?
No.
We have expressions for the two halves. But the two halves are supposed to be congruent. If we find one half, isn't the other half going to be the same? So I pick one of these to plug back into. Which looks easier to work with?
6x equals 4.
Sure, it literally does not make a difference. Now that was angle EBD, that was 6x plus 4. Remember, when you plug in, you replace x with the number in parentheses, but close those parentheses right after. 6 times 6 is 36, plus 4 is 40. Again, not what I was solving for. But I did just find that this angle is 40, or actually this one. And if that one's 40, this one's 40. Which means the full angle is 80. Once you got that, go ahead and flip the page. Can we put the laptop away during notes, please? Thank you. Now, as I mentioned before, sometimes I'm not going to give you the picture. You got to draw your own picture. Start with the biggest thing in the picture. Are angles bigger or are rays bigger? Angles. Because they're made up of 2 rays. So I draw an angle. Big enough to where I can label some things on it. That is angle FDE. Meaning the vertex is D and F and E go on the outsides. It is being bisected. Bisected means what again? Split into 2 congruent parts. Split in half. To split an angle in half, you go through the middle. That is DP. And since it's bisect, this is congruent to this. Now with bisect problems, you have to be careful with what they're labeling. The first thing it labels is angle FDP. Top little angle, bottom little angle to the big angle. D's in the middle, goes towards F, goes towards P, yep, top. That's 2x plus 7. The next one it talks about is FDE. Bottom little angle or the big one?
Big.
Big one.
Yeah, I got it right.
Is it easy to label the big ones in the pictures? Not exactly. You always have to do kind of that little rainbowiness over the angles if you're going to do it that way. It's not a technical way to do it, but it helps some people. That's 6x plus 6. I wasn't given the other little side.
So you gotta find it.
Well, they're congruent.
Kind of.
Be 2x plus 7.
They're congruent, so can I label it with 2x plus 7 again?
Yeah.
Yes.
And equals 6x.
Be careful. Them being congruent is what told me I can write 2x plus 7 here. If them being congruent is the only reason you can write this, setting these equal is not going to help you. On the last problem, we set the 2 halves equal because we were given separate expressions for them. But if you're only given an expression for one of them, then you have to do what Jackson was trying to tell us. What's going to happen with the 2 parts?
Wait, what did you add them?
You add them, and they are going to be equal to the big one. Technically, we're doing this. The measure of angle FDE plus the measure of angle PDE is equal to the measure of angle FDE. Again, I write this out because it's good practice for the future. But you can jump directly to this.
And then you gotta find like common whatever the word is.
Like terms?
Yeah, that.
Common factors is a math thing. It's not what we're doing here.
Okay.
Okay. I've got lots of x's. I combine my like terms. I notice I've got a 2x, a 2x, and a 6x. Which ones am I technically able to simply combine?
The 2x.
The 2 x's, because they're on the same side of the equal sign. 2x plus 2x.
4x.
I've got a 7, I've got a 7, and I've got a 6. The ones that I can actually combine,
14.
it was 7, 6, not 6, 7. I hate to break it to you.
I didn't even say that.
Yes, you did.
I did.
Yeah, you did.
Now, if I want to get my x's together, because that's the next thing we should do, is do opposites. X is 4. Is that what it wanted? No. I need to plug it back in. But what should I plug it back into to get the answer the fastest way possible?
6x equals 6 because
We have an expression for what we're looking for. This one, we didn't have an expression for what we were looking for. So we plugged it into something else, knowing that we could work our way to what we wanted. But if you have an expression for what you're looking for, just plug it into that one. Measure of angle FDE is equal to 6x plus 6, or 6 times 4 plus 6. You get 30. Last one, we're gonna do a little bit of setup, but for the most part, we are going to just kind of, we're gonna skip a lot of it. I wanna make sure we get it set up right, because that's what we need to practice. How do I start the process? Draw a picture and draw an angle. Label the angle. NDE. In other words, D is the vertex. What do I do with the picture next? Someone other than Jackson should know this.
Split it.
Split it down the middle.
Make it congruent.
That's J, and make them congruent. NDE. Top angle, bottom angle, or big angle?
Big angle.
Big angle. Angle NDJ. Top angle, bottom angle. Top. T goes towards N, goes towards J. Top. 2x plus 4. Is this one of the problems where I can just set things equal, or is this one of the problems where I have to add some things?
Equal. You can set them equal because they're congruent.
These are equal. These are
like-
congruent.
No, like the two little top and bottom.
Oh, this one?
Yes.
Okay, good. But can my equation just be two numbers equal and then solve? Or two things equal and solve?
No, you have to do it like the last equation.
Yes, I have to add some things together. After you solve for x, you plug back in. Okay. That is it for notes today. Yes, it is a book assignment. I have no clue what you just said.
Could have told me that in the beginning.
You could have read the board.
Don't stress it.
It's page 42, numbers 31 through 38. Remember, page 41, day 1 is due today.